Good morning, students, and welcome to another live CSEC class. This morning, we are going to be continuing our class that we had yesterday on relations, functions, and graphs. And we're actually going to be looking at the equation of the line and perpendicular lines, parallel lines.
Mr. Mike is off.
Just log on and we're going to be inside the class on YouTube. All right, so just give me a minute. So
Mr. Mike is off.
So my students come on.
She needs her mic to be off so it doesn't have lag on both the stream and the news.
You have to go on YouTube so you can hear him.
All right, so as we wait for the students to log on, let's refresh on what we did yesterday in relations, functions, and graphs. So we looked at the coordinate plane and find the length of the straight line, finding the midpoint, and find the so we had the length of the line, the midpoint. Did not get into the equation of the line. So that's what we're going to do today. And we're also going to look at, we also found the gradient yesterday. We looked at how to find the gradient. So we're also going to be looking at perpendicular lines and parallel lines and how we can find the equation of a line if we know another line that it is parallel to or that it is perpendicular to. So we're going to start with the equation of the line. And we're focusing on straight lines. So the equation of a line is y equals mx plus c, the equation of a straight line. All right, so y equals mx plus c. We have students start today. If this is completely new to you, don't worry about it. You will catch on as we go along. Right, so just listen and try to follow. And the most important thing, if you have any questions, type it in the chat. When I give you an activity to do, I want you to do your working out and post your answer in the chat so I can see if you are following. All right, so that's very important. Ask questions as we go along. And if it's completely brand new to you, don't be scared, don't feel any way. You're going to get it as we go along. So y equals x plus c. This is the standard form for the equation of a straight line. And from can tell a number of things. The M here, M represents the gradient of the line. So if you know the equation of a line, just looking at the equation, you can tell what the gradient is of the x term. So the number right here, there are letters. I'll show you in a little while. We would have numbers here and here. And the number here, the coefficient is the number that's in front of the variable. Looking at the equation, you can tell that this number here is the gradient of the line. This number that's out here is called the y-intercept. And what it tells you is with y-axis. So we know the gradient and we know the y-intercept. So for example, if we have an equation, y equals negative 2x plus 5, we could, just by looking at the equation, the gradient is negative 2, because that is the coefficient of the x variable, and the y-intercept is 5. That means this line cut the y-axis where y is 5. So let's remind ourselves what we are in the y-axis and all of that stuff. So this is, let's say this is our coordinate plane. So that's our x-axis. And this is our y-axis. So and we have our origin or 0 right here, dead center in the middle. Now, everything above 0 on the y-axis is positive. So this is our positive y-axis. This down here is our negative y-axis. This is the positive x-axis to the right of 0, and this is our negative x-axis. So if we had, let's say on the y-axis, we had a scale of 2, 1, 2, 3, 4, and so on. Negative 1, negative 2, negative 3, 1. So if we had a line, y equals 3 plus 2, the 2 out here, the y-intercept, will tell you that the line would cut the y-axis here, where y is, the line would cut it right there. And if it was y equals 3x minus 2, it would cut the y here at negative 2. So that's what this number at the end tells us. The line, and then the 3 now, 3 is in front of the x, it's the x coefficient. So that tells us the gradient of the line. So the gradient of this particular line would be 3. And what we mean by gradient is how steep or how smooth the incline, how steep or flat the incline of the line is. So to give you an idea, a very steep gradient would have something like that. So that's steep, right? This one is a little, this one is still a little bit, right? So that's what we mean. How steep the line is. So you can imagine climbing a very steep hill, it has a sharp gradient. All right, so let's look at the equation of the line then. So y equals mx x plus c. Give me a minute, please. Okay. Excuse me 1 second, students. All right, so I'm going to show you how to find the equation if we're given 2 points along that line. So let's say, for example, so let's remind ourselves, let's always put the general format, y equal mx plus c. All right, and remember, m is the gradient, y-intercept. So let's say we line, and we know 2 along that line. We know point A is, let's say 7, 6, and point B, 3, negative 5. We call these coordinate pairs. So that's another pair. The first is you where you move on the x-axis. So x is 7. The second number tells you where you move on the y-axis. So y is 6 in this case. And for point B, x is 3 and y is negative 5. So they want us to find the equation of the line. In order to find the equation of the line, we have to work out the gradient, and we have to work E, which is the y-intercept. So let's do it. Those who were in the class, we looked at the formula for finding the gradient given 2 points. And I'm going to write that formula again. So y2 minus y1 is 2 minus x1. So my seizing up a bit in a minute. So when we say y2 and y1, we're talking about the second y value and the first y value. So in this case, A and B, the first y value would be the 6, and the second y value would be the negative 5. The first x value would be 7, and the second x value would be 3. So y2 minus y1 divided by x2 minus x1. So that would be negative 5 minus 6 divided by 3 minus 7. And that would give negative 11 over negative 4. The two negatives cancel, so the 11 over 4. I'm just freed up students. So it's y to find gradient, is y2 minus y1. The second y value minus the first y value over the second x value minus the first x. Y2, this is y1. So it's negative 5 minus 6, wow, divided by 3 minus 7. The negative 5, 6 gives negative 11, and the 3 minus 6. So the grade 11 over 4. Okay, then now we need to find C, the y-intercept. So what we'll do is we will just replace we can use any pair, so this pair or this, to find C using the x and y value and plug into this equation here along with the gradient. All right, so I'm going to use the so let's use the 7 and the 6. So x 7, y is 6. So that would be, so using this equation now and plugging in those values. So if x is 7, 6, so that means 6 would be equal to the gradient, or m, times, which is 7, C. We're just plugging the values into the equation here. All right. So 6 would be equal to 11 over 4 times 7 would be 77 over 4 plus C. And 77 over 4 into 7, 1 time, remainder 3, and 4 into 37 goes 9 times, remainder 1. So that's 18 and a quarter. So 6 is equal to 19 and a quarter plus C. So bring this over to the left. A quarter would give us C. So what is 6 minus 19? So that's negative 13 and a quarter. All right, so negative . So to find the, now we just write back y equals, and it will be the gradient, which is 11 over 4 x minus 13 and a quarter. All right. All right, so give me some feedback about that one that we just worked. Do you understand? So let me see some feedback, students. All right, so let's continue. All right, okay. So Jerry is saying he doesn't understand. All right, we're going to do 2 more examples, and then I'm going to give you 1 to try on your own. And hopefully by then, Jerry, you'll get it. So let's do 2 more examples. So again, we're starting out, we're writing our equation of a straight line, y equals m x, that's the x, y equals mx plus c. So let's say we have 2 points again. We have point C, which is -1 on the x, 0 on the y, and we have point D, 4x, -2 on the y. All right, so we need to find the equation of the line. So we know the first thing that we find is the gradient. And the gradient, the second y value minus the first y value by the second x value, the first x value. So that would mean first x, second x. First x, first y. Second x, second y. So it's the y value, which is -2. The first y value, which is divided by second x value, which is 4, minus the first x value, which is -1. We put that in brackets, and -1, and we have 2 negatives working here. So -2 minus 0 is -2. 4 minus -1. So the gradient is -2/5. All right, so we found the gradient. Now we need to find the y-intercept. So we're going to plug in the gradient, plug in the x value, plug in the y value to find what C is. All right, so let's do that then. So we can use any one of these pairs. So I'm going to use a simpler pair where x is -1 and y is 0. Okay, so we would have 0, y is 0, is equal to -2/5, which is the gradient. No. Okay, so -2/5 x is -1 plus c. 0 is equal to -2/5, -1 is 2/5. So if 0 is equal to 2/5 plus c, then we just bring over the 2/5, it becomes -2/5. So c is equal to 2/5. So we just need to rewrite the equation in the gradient and putting in the y-intercept. So the answer is y is equal to gradient, which is -2/5, x, and the y-intercept is also -2/5. That's the equation of the line. Let's do one example, one for me, and then we move on to the perpendicular and parallel line. Y equals mx plus c, where m is the gradient, c is the y-intercept. We have 2 points, E and F. Point E is 9, -5. Point F is -2. And we want what is the equation of the line where these 2 points pass along that line. These are 2 points along that line. What is the equation of the line? So we're going to first find the gradient. So the gradient is the second y value minus the first y divided by the second x value minus the first, means the second y value, which is 2, minus the first, which is -5. Since we have negative and negative, we put a bracket just to separate them here, divided by the second x value, which is negative, minus the first x value, which is 9. This gives us 2 minus -5, 7. And -3 minus 9. And now we need to find what C is. So we're going to plug in as into the equation to find what C is. So I'm going to use y is 2 and x is -3. So our 2 for y is equal to the gradient -7/12 times, which is -3, plus C. So 2 is equal to -7/12 times -3. That would give a positive 3 7s 21. So positive 21/12 plus C. And 21/12, that's 1 and 9/12. So 12 into 21 goes 1 time. Remainder 9/12, and the 9/12 is 3/4. So that's 1 3/4. Right. So C then would, so C would be equals to 2 minus 1 3/4. So C is equal to 1/4. All right, so C is equal to 1/4. So we just need to rewrite the equation now, put in the value for the gradient and the value for C. So that would mean y is equal to, let me write it here. So that new equation now where y is equal to the gradient, which is -7/12, x and 1/4. So it's plus 1/4. All right, so when you're doing it, you're not going to be writing all over the place like me. You will have space in your book, so coming step by step down. Okay, vertically. You don't need to be going all over the place like this. I'm just trying to use up the space that I have available here on the board so you can see everything in one place without me having to go to another slide for the same question. All right, so I'm about to give you one now to do on your own. So let me hear if you have any questions or know you understand it now. Just say, Miss, I understand now. All right, so Ngozi is saying she understands it now, even though she was a bit lost earlier on. Are you hearing well now? Because persons are saying I was breaking up earlier. Are you hearing me now properly? All right, Jerry is saying he still doesn't understand. So what we do, Jerry, we look at and points are along the same line. So that means they have the same gradient. Points on the same line will have the same gradient. So we know what is the equation of this line. In other words, we want to know what is the equation where if we plug in any x value along that line, we will get the corresponding y value along that line. The equation of a straight line is written in the format y equals mx plus c. So we need to know what the gradient is, which is m. We need to know what c is, which is the y-intercept. So we need to find those two things. The formula for finding the gradient is y2 minus y1 divided by x2 minus x1. What we mean by y2 is the second y value. So we're given two pairs of coordinates. For example, in this case, point E is 9, negative 5. So 9 is your first value, and negative 5 is your first y value. For point F, negative 3, 2. So negative 1 F x value, and 2 is your second y value. So that's 2 minus negative 5. And we're going to divide that by the second x value minus the first x value. So that's negative 3 minus 9. And we just work that down. Negative 5 is positive 7. Negative 3 minus 9 is negative 12. So that's negative 7 over 12. That's the gradient. Now we need to find c. So we go back to our equation of the line, y equals mx plus c, and we plug in the three things that we know. We know our y value, we know our x value, we know our gradient. You can use the 9 and the negative 5 for your x and y, or you could use a negative 3 and the 2. I decided to use the negative 3 and the 2, plug those in, and then found what c was. So once you're on the gradient and you find c, just put them back on. Y equals what? Plus. So I'm going to give you one now to try. On your own, and then we're going to go on. We have two points on the same line. Point G, which is 0, 4, and point H, 7, 0. I want you to tell me what is the equation of this line where these 2 points fall along the line. What is the equation of the line? So remember, the first thing you do is to find the gradient using that formula, y2 minus y by x2 minus x1. Then find the y-intercept by plugging in your gradient and any two of the x and y values that are given. Find what c is, and then just rewrite the equation, putting in the gradient and c. So do that for me, and as soon as you're finished, post your answer or post your question if you have a question. So that's what we're doing now. Go ahead and work out work out the equation of that line for me. All right, so remember, as soon as you get your answer, just post it. Or if you're not sure, if you're at a particular point and you're not sure what to do, just ask a question. In some answers coming in already. Semani is saying she got -4/7 as the gradient and 4 as the y-intercept. So Jamani got the same thing, and he's saying his equation would be y equal -4/7x plus 4. All right, let me see the other students posting their answers. Admit. Remember, when you're substituting the values, each one of pair of coordinates given. So you could use point G where x is 0, y is 4. You could use point H where x is 7 and y is 0. All right, so Ngozi is saying just sounds a little better. You're welcome, Ngozi. All right, so where are the other answers? Come on, guys, I'm waiting. You shouldn't take so long to do this one question. Voila, there you have it. So let's go. Let's work it together. So we have point G, 0, 4. Point H is 0. And we know to find the gradient is the minus the first y value divided by x value minus the first x value. So that would mean second y value is 0 minus the first y value, which is 4, divided by the x value, which is 7, minus the first x is 0, and that gives -4/7. So that's our gradient. Our y-intercept, or C, we need to plug in the gradient, which we just found. We're going to plug it here where m is. We're going to plug in a y value and an x value. We can this and this, or this and this. So x, y, or x, y. So I'm going to use H. I'm going to use point where x is 7 and y is 0. I decided to use that because I'm looking at the gradient and I'm seeing there's a 7 in the denominator, which would work well if I'm multiplying it by this 7 in the x, right? So sometimes you can just make a quick scan to see which one is better, which pair is better to use based on if you see where a certain number is divisible by another one, you can easily reduce it, then you decide to use that one. But whichever pair you use, you should end up with the same answer. So I'm going to put 0 for y and 7 for x in this equation here, and -4/7 for m. And we're trying to find c. So 0 for y, m, then -4/7 times x, which is 7, plus 1. So these two cancel out, and that's what I was talking about. This 7 cancel that because we're multiplying here, so it cancels. So we have 0 minus 4. Sorry, 0 is equal to, wrote the wrong thing. So it should be 0 equal to -4 plus c. So we need to go about that. Negative to the left, it becomes +4. So c is 4. So we found the gradient is -4/7. C is 4. So we're going to put the gradient here, put 4. So we rewrite the equation then. Y is equal to -4/7 x plus 4. And our answer, the equation of the line. So now we're going to go on to parallel and perpendicular lines and how we can use whether a line is parallel or perpendicular to another line. We can work out what the equation of all right. Now, if two lines, let me first draw what we mean when we talk about parallel and perpendicular lines. All right, so parallel lines meet at right angles. Scratch that. That's nonsense. Sorry. I mean, perpendicular lines meet at right angles. So parallel lines don't ever meet each other. They are either horizontally, they would look like that. Vertically, they would look like that. Or diagonally, they would look like that. Parallel lines never meet. They are they should be perfectly straight. We're going to imagine that these ones are straight. So have equal distance between them at all points. So let's pretend that these are perfectly straight, equal distance between them. So these lines are parallel. What's important to note for this, in this case, is parallel lines have the same gradient. That's important. So if a line is parallel to another line and the first line has a gradient of 2, the line will also have a gradient of 2.
Miss?
Yes? Good morning.
Miss?
Perpendicular lines
Miss?
Can't ask her for stuff when she's eating. think this is like can't accept for something.
Correct.
If two lines are perpendicular, they'll be the negative inverse of each other. So let me draw what perpendicular lines. Perpendicular lines meet at right angles. So then this is a straight line down, straight line across. Use your imagination. Straight line down, so vertical, horizontal, they meet at right angles, so they are perpendicular. In terms of the gradients, perpendicular lines have negative inverse gradient. What do we mean by that? If one of the gradients, then the gradients of the other will be negative, right? That's what we mean by the negative inverse. So the inverse of 2 is a half, we make it negative. If one of the gradients is a quarter, then the other gradient will be 4 if they are perpendicular to each other. So using that now, bearing that in mind, let's see how we can find the equation of lines if we know that the lines are parallel or perpendicular, and if we know another line that they are parallel to or perpendicular to. Say, for example, we have a line that has a gradient of, let's say this is the equation of the line, equals 2x plus 6. That's the equation of, and we have another line that is parallel to it, to this line, and that other line, let's say there's a point along that line, 7, -4. This line that has this point on it, what is the equation of that line? So remember, the general equation of a line is y equal mx plus c. If we know the gradient, and if we know an x value and a y value that correspond, we can find c, and then we can find the whole equation. So since this line is parallel to this line, that means they have the same gradient point here. The gradient for this line is 2, just like this one, since the line. So we can use 2 as a gradient, and we can plug in our x value and our y and work out what c is, and hence find the equation of that line. So let's do that then. We know m is 2, we know x is 7, and we know y is 4. So is equal to the gradient, which is m, that's 2, times x 7 plus c. So -4 is equal to plus c. So -4 plus 14 is equal to c. So c is -18. And now that we know c is -18, we just put into the equation. So the equation of this line here would be y is equal to the gradient, which we know is, since the lines are parallel, we know the gradients are going to be the same. So that's 2x, and c would be -18. So that is the equation of this line. We knew first was a point along that line. But since we knew the equation of this line, and since we know that the lines are parallel to each other, we know they have the same gradient, so we can use this same gradient and plug it in with these coordinates to find the equation of that line. I want you to try this one now for me. So we have a line that has an equation y equals negative 8x plus 9. So negative 8x plus 9. That's the equation of this first line. This other line is parallel to the first line, and a point on the second line is 3, 8. They are parallel. I want you to work out for me the equation of this second line. So work out the equation of the second line. So it's two lines. It's two lines we're dealing with. The equation of the first line is y equals negative 8x plus 9. We don't know the equation of the second line. That's what we're trying to find out. But we know that since it's parallel to the first line, they have the same gradient. So we can use that same gradient and then the point, the x value and the y value to find the equation of the line. So do that for me. You should be able to do that in 2 minutes. Plug in the values that you know and find the equation of the line. As you go along, if you forget something, if you have any question, let me know. I'll help you to clarify that. All right, Ngozi, you don't get the canceling part. Which canceling part are you referring to? You want me to go back to the first slide before this? All right, let me go back to the first slide. Which one you ask? Which part you're asking about? Which cancel? That slide there? I didn't do any canceling in that slide. Let me know which one you're talking about. And okay, so Jamani says he got y equal negative x plus 32. Ngozi, let me know which section in particular you're asking about. I didn't do any canceling example on the screen now. So let me know which one you're talking. All right, let's work this one together. We always want to write our general equation of a straight line. So we know what we're working with. Y equals mx plus c. And m is the gradient, c is the y-intercept, which tells us where the line will cut across the y-axis. Now, these are two different lines we're looking at. For this one, we know the equation of the line. We don't know any point along this line. We just know the equation of the line. We know where it crosses the y-axis at 9. We know the gradient is -8. This line, we don't know the equation. They want us to find the equation, but they told us a point along that line. And where x is 3, y is 8. We know this point. We know the coordinates for this point. What's good about this is that we are told that the lines are parallel. And from here, we know that they have the same gradient. Parallel lines have the same gradient. That means the gradient of this line is also -8, like this one. So we can use that information now to plug it into this equation here to find C. And once we find C, we're going to rewrite the equation, plugging in the gradient and the y-intercept. So let's do that. So we know x is 3, y is 8, and the gradient is -8. So y is 8, so we're going to put 8 is equal to m, which is the gradient, -8, times x, which is 3, plus c. So this is just now a matter of algebra, working it down. So -8 is -24. So now to have c itself, to transpose or to isolate the c, we're going to add 24 to both sides, or we could say we're moving the -24 across to the left and the sign will change. So we'll have 8 plus 24. 8 plus 24 is 30. C is 32. All right, so if gradient is -8, that's m. We know C is 32. So we just need to rewrite the equation, putting in those values. So it's y gradient, because they're parallel, plus 32. So this line will axis at 9. This axis at 9. That's 32. The two lines are parallel. This line here, this one here, will cut the y-axis at 9. And this line here, the y-axis at 32, like that. Right? Okay. So let's look at perpendicular lines now. I give you one to do, and then we wrap up this session. And perpendicular lines, as we said before, they meet at right angles, and they have their gradients are the negative inverse. So if we are told that two lines are perpendicular, we just find the negative inverse of it. So let's say we have this line, y equals 4x plus 9. Their there's another line that's perpendicular to this one, and we know a point along that line, -4, 5. Is the equation of this line. All right. Since the lines are perpendicular, the gradients are negative inverse to each other. That means since this gradient is 4, the negative inverse of 4 is a quarter. That means the gradient of this line is negative. So we just need to plug that into the formula y equals mx plus, and find what c is. So in this line, x is -4, y is -5. So -5 is equal to, which is -1/4, times x, which is 4, plus -1/4 times -4 would give a +1, because so that 4 would cancel this one. So we're multiplying a quarter times -4. Negative times negative give positive. So we'd end up with a +1 plus c. And now we subtract 1 from both sides. So c would be equal to -1, which is 6. So we know our gradient is -1/4 for this line, similar to this one. And we know the y-intercept, or c, is -6. So we just need the formula now. C is equal to the gradient, -1/4, x, and the y-intercept is 6. Okay, so let me give you on your own, and then we're going to wrap up this section. So let's say we have a line. All right, let's say we have a line, and the equation of that line is y equals -5x minus 3. Line that has a point 6, 2. Lines are perpendicular to each other. So find the division of this line. So that's the last thing we're doing in this session, parallel and perpendicular lines, right? Find the equation of that line. The two lines are perpendicular. We know the first line. We know a point on the second line. So the two lines will meet each other at right angles. What is the equation of the second line? So again, I'll give you 2 minutes to work that one. All right, any answers yet? So the first equation, y equal negative 5x minus 3. And then we have another line that cuts this one, meets this one, intersects this one at right angle. At a right angle. So let's go. Since the lines are perpendicular, we know that they meet like this. So one is coming in like that. The other might be coming in something like that, right? That's how they meet each other. They create a right angle to each other. Whichever way they're going, they're oriented. Or if we have one, if we had one going, yeah, that's basically how they would meet. We had one going this way, they could meet each other like that, those lines. They meet at right angles. All right, so we know the gradients of this line. So if the lines are perpendicular, their gradients are the negative inverse. So the negative inverse of negative 5 would be 1/5. So we know that the gradient of this line is 1/5. So using our equation y equal mxc, we can plug in the gradient, plug in 2 for y, plug in 6 for x. So we would have 2 is equal to 1/5 x plus c. So 2 would be equal to 2/5. So 2 minus 2/5 would be c. And 2 minus 2/5, 1 and 3/5. All right, so 1 and 3/5. So we would write that back now, write back the equation. So to be y is equal to the gradient, which is 1/5 for this line, since it's perpendicular to this one, the 1/5. So 1/5 x plus c, which is 1/3/5. All right, so that's that. If you still have questions and comments, you can post them in the chat or section, and I'll get to. So we're going to wrap up this session now and start another session for